In this lesson, we'll be looking into adding and subtracting algebraic terms. So the main rule when it comes to adding and subtracting two algebraic terms is that those two algebraic terms need to be like terms. So let's write that down. Now if you don't know what like and unlike terms are, I've covered that in my previous video. You can find the link to my previous video on the top right corner of your screen or in the description below. So let's take an example. 3x plus 4x. Now as I mentioned already, they have to be like terms first, and you see 3x and 4x are like terms because they both have the same variable. So the way you add is that you add the coefficients together. So you add 3 and 4 together. So the answer is 3 plus 4, 7x. Some students have the misconception thinking that when you add 3x and 4x they become 7x squared because there are two x's there. But that's not how it works. You can think about this like counting lollipops. Say for example you have 3 lollipops, so 3 lollipops there, plus your brother has 4 lollipops. Now if you think about the total number of lollipops you both have, that will be 7 lollipops. And you don't say 7 lollipops squared or anything that's similar, right? So when you're adding two algebraic terms, what you're doing is essentially just adding the coefficients, because it's just 3 of something and 4 of the same thing. It's just 7 of the same thing, right? So 3x plus 4x is just 7x and not 7x squared or anything else. Let's have a look at an example of unlike terms. Say 3x plus 4y. As I mentioned previously, you cannot add unlike terms. So if the question says 3x plus 4y, the answer is just going to be 3x plus 4y, because you can't simplify that anymore. That's the final answer, 3x plus 4y. Now if we give the same kind of an interpretation here, we can think about x as chocolates. So 3 chocolates and 4, I'll say, toffees. Now let's say that you have 3 chocolates and 4 toffees with you. The simplest possible way that you can tell that is just to say that you have 3 chocolates and 4 toffees. It wouldn't make sense if you said 7 chocolate toffees, right? So just like that, it wouldn't make sense to add these up together and say 7xy. This is also a misconception among the students that 3x plus 4y can be added into 7xy. And now we see with the example that I mentioned that it does not make sense to say that you have 7 chocolate toffees when you have 3 chocolates and 4 toffees. So the simplest possible way that you could say that is just to say that you have 3 chocolates and 4 toffees. So just like that, if it's 3x plus 4y, the simplest possible way that you can say is just to say 3x plus 4y. So we understand that we can't add unlike terms, we can only add like terms. Now let's go ahead and try out some examples. Let's start with the first question. 2x minus 4y plus 3x minus 2y. You can clearly see that 2x and 3x are like terms, and minus 4y and minus 2y are like terms. So let's put them together. 2x plus 3x, that's just 5x. And then minus 4y minus 2y. Minus 4 and minus 2 gives you minus 6. That's minus 6y. So that's the answer to the first question. Now the idea here, as you might have noticed, is to group all the like terms together and solve them separately. Now let's try the same thing for the second question. 5a negative 2a plus 3a. These 3 algebraic terms are like terms, and positive 4b, negative b, and negative 2b. These 3 are like terms. So we'll simplify the a terms separately and then the b terms separately and then put them back together. So let's see here, 5a minus 2a plus 3a. So that's 5 minus 2 is 3. 3 plus this 3 is 6. So that's 6a. Let's put the equal sign. And then we have b terms together. 4b, this is minus b. When you say minus b, as I've already mentioned, when you don't see a coefficient, that means there is a 1 there. So by default, it's minus 1b. So 4b minus 1b is 3b. 3b minus 2b is just 1b. So that's just 1b, or you can just write it as b. 6a plus b. By the way, if you want to pause the video and try the rest of the question by yourself, feel free to do so, and then resume back to see how it's done. Alright, so let's go to the third question. We can see that 10x and minus 6x are two like terms, and these constants minus 15 and plus 8 are like terms. So let's solve this. This is equals to 10x minus 6x, that's just 4x, and minus 15 plus 8. Minus 15 plus 8 is minus 7. Moving on to the next one, we see f squared terms here. So 4f squared and negative 9f squared. Now we have to remember something here. Whenever you're selecting an algebraic term, it always comes with a positive or a negative sign, which means the sign that belongs to the term is the one that's before it. So instead of underlining, if I can just box it out, I will say that this 4f squared and negative 9f squared with the sign, these two are like terms, right? So they are both f squared terms. And then negative 3g and positive 4g are like terms. So what you have to notice here is that the sign always belongs to the term that follows it. So when you're grouping the like terms, we need to make sure and we need to be careful that we are also choosing the signs properly. Now if you simplify this, 4f squared minus 9f squared, so that's 4 minus 9, that's negative 5f squared, right? Let's put the equal sign, negative 5f squared. And then negative 3g plus 4g is just plus 1g, or just you can just say plus g. Okay, let's go to the next one. 2xy and negative 5xy are both like terms, and at the same time positive 3ab and negative 2ab are like terms. So if you simplify this, 2xy minus 5xy, so that's 2 minus 5, that's negative 3xy, and then plus 3ab minus 2ab is just plus ab. That's basically 3 minus 2, which is 1, and when 1 is a coefficient, we just say ab. Alright, if you see the next one, you will clearly notice that all of these terms are like terms. Starting with phi x, y, z, this algebraic term contains the variables x, y, and z. So does this term, and this term, and this term. All four of these terms contain the same set of variable x, y, z. The only difference is that it's just in a different order. And we saw in the last video that the order doesn't matter when you're considering like terms, as long as the set of variables are the same. So since all of these are like terms, we just have to add them all together. So 5xyz minus 2yxz plus 9zxy minus xyz. So this basically, if you only consider the coefficients, 5 minus 2, that's 3. 3 plus 9, that's 12. 12 minus 1, that's 11. So 11 x, y, z. Now it doesn't really matter which order you write the answer as well. You can say 11 xyz or 11 yxz or 11 zxy or 11 zyx. It doesn't matter, right? Because as we've already seen previously, the order doesn't matter. So since there's a mixture of order here, it doesn't matter whichever the order you write. Okay, for the last question, it says 3a squared bc, 3abc squared, and 5ba squared c. So to find the like terms in this set, let's observe the variables very carefully. The variable that is squared in the first term is a, while the variable that is squared in the second term is c. So clearly these two are not like terms, these two are unlike terms. And when you come back again to the third term, again the variable that is squared here is a. So this clearly tells us that the first term and the third term are like terms. So this one and plus 5ba squared c, these two are like terms, and this one is a separate term. Since this term in the middle doesn't have any partner to simplify with, it will just remain as it is, and we'll just simplify the orange ones. So this is equal to, let's look at the orange terms first, 3a squared bc and plus 5ba squared c. So that's basically 3 plus 5 is 8, and it doesn't matter which order you write as long as it's the same set of variables. So it's 8a squared bc, and then this purple term will just remain as it is, 3abc squared. Hope you understood this lesson. If you liked the video, hit the like button and subscribe for more similar videos. Also feel free to comment below in the description if you have any questions or if you have any topics that you want me to discuss in my future videos. See you soon.